Good afternoon, everybody. This is Jordan Frazek from Applied Geographics. This is the Google for .gov Solving Problems with Google Maps Platform webinar. On behalf of Applied Geographics, or AppGeo, I'd like to thank everybody for joining us today. Alrighty, it is 2:01 Eastern Time, and we do have quite a bit of material to cover today, so we will get this presentation started. Once again, this is Jordan Frazek, Marketing Automation Manager here at Applied Geographics, or AppGeo. I really appreciate everybody joining us today for the Google for .gov, or government webinar, where we're going to talk about solving problems with Google Maps platform. And we are very pleased today to be joined by Greg Grube, the GIS election specialist for the Wisconsin Election Commission. We will also have Aaron Doucett here, which is a sales engineer over at AppGeo. And Aaron, are you there today?
I am. Thank you.
Excellent, excellent. So I guess before we jump to the next slide, I will finish introducing Greg on his behalf. So Greg has been providing over 10 years of GIS services for government agencies. He's worked at a variety of levels of government, and he is developing best practices and documents for the NISJIC Geo-enabled elections project, as many of you may be familiar with as well. Unless Aaron, actually, if you want to talk a little bit more about yourself too.
Sure thing. Aaron Doucett here with AppGeo. I come from a GIS background myself, with a strong focus on building applications for the web, working with a number of cities and towns on a variety of projects. And through that process, I've kind of gotten a firsthand look at what it takes to build community adoption of some of the tools that we're going to look at today. And my role at AppGeo is about helping our customers do just that. So I'm happy to be sharing this all with you today.
Excellent, thank you, Aaron. And so just to let everybody know, if you just joined us, we do have attendees here from across the country, about 30 different states represented and a few provinces as well. So I'd like to first start the agenda today by introducing, like I said, Aaron and Greg. And the next thing that we'll do, we'll dive right in after this agenda, is talk about Google for Government, how all levels of government are using Google Maps platform. Here at AppGeo, we are one of Google Maps' premier partners, so Google Maps platform partners, with a location-based services specialty. So we work with, like I said, all levels of government in their implementation of Google Maps platforms, and we'll show off some great examples of those today. So we'll talk about how we work with government agencies and entities to power real use cases, and then from there we'll talk about how to build with Google Maps applications, so with Google Maps APIs, and how to solve business problems in real time. Aaron, I think you can take it from here.
Great. Thanks, Jordan, and welcome, everyone. We're really happy to have you. I know it's been a pretty intense week, and we really appreciate you taking time out of your schedule to join us today. And I know many of you are starting different accommodations, maybe working from home. So we're really happy to have you and be part of this presentation. I wanted to first introduce just a little bit about AppGeo, the group behind the presentation here today. We are a Boston-based consulting firm who have our bread and butter in all things geospatial. That includes, the mapping part, but also the data part that goes behind it. And we've been doing this for over 28 years, helping a lot of cities, towns, all levels of government, all the way up to state and federal level. And for the past several years, we've been developing this partnership with Google, who have the Google Maps platform, which is what we're going to look at today. And we are very dedicated to developing with Google technology, be it in the cloud or on the Maps side. And we're going to show you some great examples of how we've achieved that and what we're looking to do going forward. And we'd like to share that, beyond just the cartography, beyond just the technology, we're really a group that likes to work within the strategy, the process and coordination that come with projects at all sizes. We'd be happy to chat more about kind of our past projects and experience and all those sorts of things, if everyone wants to set up a one-on-one talk afterward. So I'd like to dive into a question that a lot of you might have: what makes Google different? And in the world of mapping software, there's a lot of players, and ultimately they all produce a map at the end. But the end product is really only a small part of the story. And we also have to look at how we got there. Where did this information come from? How is it going to change? And at Google, they've been investing in their mapping program for 15 years now. and have gone to some pretty interesting lengths to add depth to their platform and data sets. This includes Street View imagery on over 10 million miles of roadway. They've gone beyond the road now to underwater and hiking the deserts and mountaintops with backpacks. And, at the core, they have a pretty strong foundation of people who really love this stuff. And I think that really shows in the end product. To reiterate, I don't work for Google, but I work with Google, and I've gotten a chance to interact with a lot of their staff, and we've seen the investment that they've been putting into the program from that perspective, and it's really on the rise, and that's why we want to help connect the great things they're doing with the government audience that we know so well. Speaking of investment, there are a number of projects that you may have heard of or seen that are ancillary to the Maps platform, but actually have helped it grow and develop over time. So some of the things that they're doing with in-car integrations or even self-driving cars or Waze, which many of you may have used, all of those stemmed from the Google Maps team originally, and the data that's collected through these programs is often fed back up into the main Maps program. So you can look at these as like test beds for innovation, projects that have gotten significant investment and are really charting, brand new trails when it comes to the way that we use technology in Maps. Additionally, just looking at the scale of the platform, there are over 1 billion active users around the world, so more than everyone in the United States a couple times over. 60 million of those are active Google local guides who submit information on places, whether it be reviews or hours, or submitting corrections to, say, the phone number for a contact. These are people that help keep the platform up to date and enrich it on a daily basis. And again, thousands of Google engineers and Map staff, in addition to what we provide at AppGeo, behind the scenes, making sure things run smoothly. And many of you may have been familiar with the features of Google Earth, which actually predates the Maps platform in many ways. And as a map lover myself, it's exciting to see a ton of the richer features on the visualization and the 3D side are now being rolled into what you can get right on the web version or even mobile version of Google Maps. This includes things like 3D models of buildings throughout cities and terrain features of mountains, and it's becoming a visually stunning product in addition to a feature-rich one. Looking at the data accuracy, a couple of statistics here that are pretty interesting. Every single day, there are 25 million changes made throughout the global platform. And as you can see here, some of these graphics just representing what that looks like on a one-day basis of how much new information is being brought into the platform, either through place updates or traffic conditions. It's really a living data set rather than a snapshot in time. And we'll address this topic of performance a little more with some key examples, but what's pretty unique about the Google Maps and Google Cloud platform at the front of everything is that it lives on the same infrastructure that powers the Google search engine and YouTube, for example, and many other high-performance sites. And this means that whatever you throw at it, Google Maps is going to be able to handle without lags or slowdown. It's truly a scalable product that is pretty unprecedented in the world of GIS, where typically we've seen this being a major issue when it comes to getting bigger and serving more constituents. Going a little deeper into what you're actually seeing on the front end, when you have a custom application built on Google Maps, you have a bit more control over what the look and feel of the experience is. So on the left, you kind of see the Google Maps application that you might have from a consumer view. And after some customizations, you can really dial in, what features do I want to show? what type of businesses and landmarks do I want to draw attention to? Even things such as the styling. We'll get into that in a little more detail later, but again, a key differentiator is the ability to make those customizations as you see fit. Echoing what I'd mentioned before, whether you're building a custom app with Google or simply integrating their default apps into your site, chances are people have used something similar before. And we've heard this is one of the number one reasons people find apps based on Google are friendly and intuitive, with a learning curve that makes them much more accessible to a wider audience, is that at the core, the application you're building is going to be familiar to a lot of people before they've even used it. And that sounds crazy, but with so many people using Google Maps to navigate in their car or to do research on their home computer, they're coming into something that's familiar and, again, intuitive. And especially as we're going toward a more mobile-oriented world, we found that to be really important. I wanted to share one testimonial from a couple of customers on the platform. The city of Chicago, for example, found savings in the millions of dollars when they developed an application to track upcoming construction projects across the city and allowed different contractors to better coordinate their work, so the same street wouldn't have to be dug up 3 times in a row in 1 month. And again, the familiarity was a key component that made this adoption successful, because many of the end users already had a base familiarity with the platform. They didn't need additional training. And rather than it being something that's now a burden to learn how to use and get familiar with, they were able to hop right in and understand the functionality. And this is a testimonial from one of AppGeo's own customers, the Texas DOT, who rolled out an application based on Google Maps called Drive Texas. And we'll take a look at how that works in more detail later. But I wanted to share this quote from James Bass, who was thankful to have this resource stay online when it really mattered most during Hurricane Harvey. And their application just during the course of the storm, when they had some major infrastructure changes and emergency response going on, over 3 million views. So with that, I wanted to get into a little more depth about how this actually all comes together, with an overview of the APIs within the platform, the actual bread and butter of what's going on behind the scenes. And it's interesting timing in that as of this year, Google Maps has turned 15, and there are more than 5 million websites and apps who tap into the platform every week, which is a pretty considerable growth from where it started 15 years ago. So getting started, the Maps platform is grouped into 3 main categories consisting of maps, routes, and places. And before I get too much further, I'll explain. Some of you might not have a huge amount of familiarity with what API is or why you would want that. It's short for Application Programming Interface, and that might sound scary at first, but really it's just a shorthand for a way of communicating with the Google Maps servers to get the information that you want. And they're really made to make your life easier rather than harder. And they're set up in a way that you don't have to have a huge programming experience to get started. And honestly, the data that you are inputting and getting back ends up being quite simple. And what we're going to do today is take a look at all the different ways that you can achieve that using these 3 areas. So let's get started with APIs for maps. And this is where you have access to all of the Google Maps that customers and constituents are familiar with, such as those base maps and satellite maps. And believe it or not, there's quite a large degree of customization that you can do on top of that. And that's all within this Maps JavaScript API, a version of Maps which runs in JavaScript in a web browser. There's also the Maps Embed API, which can work directly in a browser similarly, but has a few different parameters. The Street View API, many of you may be familiar with, driving around on Google Earth Street View, you can enable that into your application as well, where you can give it an address, and it'll return the street view for that exact location. And the map static API is actually quite useful for examples where maybe you don't need that dynamic scalable map that you can zoom in and out on, but instead just want to include a photo with a pre-built map with certain parameters. And that's where the static API can automatically generate that for you. Going a little bit further, APIs for routes has some really powerful features such as turn-by-turn directions through the Directions API, distance matrix, which is like a supercharged version of directions where you might have, say, a one-to-many relationship between a fleet of vehicles and either deliveries, check-ins, or logistical needs. It will find the most efficient way to do that. And the Roads API, which actually comes into play when you might be doing live vehicle tracking with GPS, giving you a clear idea of exactly where a vehicle has traveled, even when GPS data itself might be sparse, such as through a tunnel or under tree cover, places where you could have dropouts. And Places. Places is one area where Google really shines because they're tapping into the vast content library that Google keeps up to date on a daily basis for millions and millions of locations. And that's a little bit what you were seeing before. So there's quite a few modules to the Places API. The core version can serve up details like the hours of operation, time zone if you're operating across time zones. It can automatically calculate where a user is and make sure that they're, getting the right hours for their time zone. The geocoding API is particularly useful, and knowing a handful of use cases I've worked on myself in the government space, being able to go between addresses to geographic coordinates or the other way around is really powerful. And we can get into that a little more in depth, but I would say the geocoding API is one area where I think Google really outshines a lot of the other services that are out there. And the geolocation API is pretty interesting. That's where on a cell phone or other device, even without GPS, using cell phone towers and Wi-Fi, they can get a very good idea of where a user might be and ping that location back to the map. You may have seen this yourself if you've gone to a website and they say, allow us to know your location. Well, sometimes that's what's going on. And the SDK and Android libraries you see here, these are just more ways to bring these features to mobile devices. Often with the APIs you're seeing here, there's more than one way to access them, and because they know people are coming in from all different devices and needs from an infrastructure standpoint, they make that really easy. So this all sounds great, but how do we make these work together and actually put an application that can give us some value out? So let's think about some of the services that are on the go when it comes to the public sector. We might have health and environmental services doing inspections of buildings and restaurants and all across town. Public housing and assistance, where we might have at-home check-ins or inspections there. The engineering and DPW departments who are managing assets all over town and might have a fleet of vehicles and equipment and, say, snowplows, for example. Mass transit, busing, or even 311 services, and not to mention police and fire departments. These are all agencies that rely on getting to where they need to be with efficiency and speed, but also keeping track of quite a lot of assets that are on the move on a daily basis. And Google's a really powerful platform to not only visualize that, but have the data to back it up afterward and help in your decision-making and planning process. So like our example here from Boston, where we can see that taking one road might be 14 minutes versus 8 minutes, and avoiding a road closure that may have popped up just that morning. These are things that really can add efficiency when we have organizations on the go. Additionally, from a citizen perspective, we have these traffic layers, but also walking and bicycling networks, which are used in the routing and directions as well. So whether we're in a car or a bicycle or on foot, we're actually able to get a different set of directions that takes that into account. So we're not trying to bike on a highway or drive on a footbridge. This is pretty critical when it comes to providing services to citizens in a world that's becoming increasingly multimodal. And a lot of what Google can do goes beyond the map. In fact, in many cases, these APIs can be used without the need for a map component at all, which is interesting considering it's called Google Maps. But this is one that you might have actually seen in your own daily life, and it's called the Autocomplete API. And it's an incredibly popular way to improve form fillouts and get accurate information into your system with as little headache as possible. So you can see here that as I began typing just the first couple letters of the address, based on it knows where we are, it can actually fill out the rest, and with just one click, I now have every field populated, but also knowing that that was done without any errors. So this can save a huge amount of time when you might have to be going back in and fixing little typos that could cause problems in your system. Anyone who's worked with databases knows that just data accuracy and keeping things clean is probably where you can spend 80% of your time. So, having the correct zip code coming in makes your life easier, but it also makes the end user speeding up their process, and just all over a big win-win. And I'm sure many of you have found this helpful when you're checking out at an online store. You can use it for your own purposes, like in this case, we're talking about voter registration, but also, anytime a constituent might need to enter information like applying for a permit or signing up for an event. I found it really great. So it's worth mentioning that all of these topics we're talking about are just one component of a much larger cloud ecosystem. And working within the Google Cloud has a lot of benefits, far more than we can cover in this one webinar here today. But I wanted to point to a select few that I picked out to share with you all. So ranging from improved security and scalability, you also have access to some of the most cutting-edge language and translation tools, letting you communicate with a far larger audience, as especially cities and towns across America are becoming more language diverse. You're also getting the peace of mind of Google's security and all of their data protection. And they take that very seriously and have very complicated and robust systems in place to ensure that when your data is in their cloud, it is private and provisioned exactly how you need it to be. As security is becoming increasing concern, especially in the local and regional government space. And lastly, the scalability factor, which we'll look at with a couple examples. Your data can be viewed by millions of people and still function flawlessly, which isn't always the case when you build things from scratch. So in this next section, I'd like to talk about some of the places where we've taken all of these tools and built some real-world applications that are currently powering organizations' capabilities at different places around the country. These are just a couple areas where we've been able to do this for transportation, disaster preparedness, smart, sustainable cities. So being able to bring dashboards in to improve how you look at tax parcels and transit. And also what we've been seeing on a larger scale for both the public and private sector is just the process improvement that comes with modernization, bringing your data into the 21st century and maybe into a more intuitive and accessible format where all of a sudden it's not stuck within one person's capability of access. It's now distributed across an organization with tools that many people can use. And we'll look at that too as we go on. So this is one example that AppGeo has built on the Google Maps platform, and that is the university map for Rutgers University in New Jersey. And one of the larger public university systems on the East Coast, they have over 70,000 users between students and staff and visitors on a yearly basis. And by building on the Google Maps platform, they were able to take all the things that are great about Google Maps, like the street view and flexibility across devices, but then also bring in their own data. And this is really key because it's what you may not have gotten to see if you've only had exposure to the off-the-shelf Google Maps. And this is where we can, in this example that's looping now, you can see they brought in not only building footprints, but things like parking lots and bus routes. A really great way to let people navigate across their campuses as well, since they're distributed around the state with 3 major campuses, and each one has multiple areas. Being able to go from that statewide scale immediately down to a regional scale, down to the building level scale, and then drop inside that building with Street View is a feature that we feel is really unique to what Google offers. And Rutgers has been really happy with this. We've gotten to show it off quite a bit, and really proud of what they've been able to build with the help of Google and AppGeo. This is another really cool example built on Google Maps from a transportation company based in New York. This is a group that's primarily involved with the transportation of students and busing. And in recent years, they enlisted AppGeo's help to revolutionize their procedures and processes. And they went from completely paper scheduling and essentially the itinerary for each vehicle planned out as a paper route to going completely digital. And what that's let them do is have a much more flexible mechanism of changing, say, where students being picked up from, or how many students, the end location, the start location, but also navigating their vehicles at the most efficient route. As you can see here on Long Island, traffic can be a concern, and being able to find the most efficient route with traffic or construction or closures in real time can save a lot of headaches and honestly lower the operating costs, as they're spending less time idling in traffic. And there's quite a lot that goes on the back end for this application as well, which has really helped with how they can manage their staff, how they can manage their fleet. And it's all possible through the Google interface. And another really, in my opinion, interesting example where you're tying more than one component of the platform together in one application. And that brings me to Drive Texas, which I mentioned a little bit earlier, but I want to get into a bit more detail on. This is an application that was actually built several years ago and integrates Google, Amazon, and Esri components, so it's truly a cross-platform application. And because the application is built on Google, there were a handful of features that really helped make this story a unique one. As many of you know, Hurricane Harvey impacted the Houston area and, quite honestly, coastal Texas just a couple years back now, and that resulted in some major closures to roadways and actually activated the state's contraflow emergency response, where major highways were turned one way to facilitate evacuation operations. And what this means is an application that normally saw about 1,000 sessions per day suddenly was getting more than 700,000 sessions per day. And not only are individuals involved in evacuating themselves relying on this application, but those in the agency who are needing data from various agencies, whether it be tapping into live traffic cameras or getting information on whether a roadway is flooded or not. This application facilitated all of that during the emergency, and we are happy to report that it was able to do it with absolutely no slowdowns or crashes. And you can see here just the traffic that the application was experiencing from 2016, 2017, up until September when the storm occurred, the August-September timeframe, when suddenly there were millions of views instead of thousands. And this occurred again with no crashes or performance degradation due to the scalable nature of the map's infrastructure. So on a normal day, the application might look a little more like this, where we have a real-time look into the construction that's going on, the traffic conditions, and upcoming construction projects. But during Harvey, as you can see on the graphic on the right, it's just a difference between one day. The amount of closures was all reflected in the application in real time. So we've covered maps, places, routes, and showed some examples of existing applications. But how hard can it really be to build something new from the ground up? And I want to talk you through an example of doing just that. And when asked what are some of the biggest challenges facing local governments, I did a bit of research into this, and one of the biggest responses I found was issues around people wanting to increase citizen engagement, get people more involved with their community, more involved with their government at a local and regional scale. And with election season in full swing, I think many cities and towns are starting to think about ways to improve their processes while still remaining weary of understanding creating too much change too quickly could alienate those who aren't as quick to adopt new technology. So how can we balance that between not wanting to, not innovate, but also looking to put something out that people are going to find easy to use and not overwhelming? And let's take a look at how that can be done. So I wanted to show an example that I put together about building a polling place locator, as up until just a couple of days ago, the election was probably the biggest concern on a lot of folks' mind. We've probably pivoted in some ways. So I wanted to use this example as a way that you can quickly spin up a map to display a large number of locations that specifically might need to go to. I used polling places for this example, but in our current developing situation, locating public health resources might be equally, if not more important. So use this as an analogy that could be applied to a number of examples. So I wanted to use an example of system transformation here. And this is something that I did as just an example, not an official project, but to share with you a start place and an end place. And here we have a city just across the river from Boston where I've spent a lot of time. And they historically have published a PDF map of all of their polling locations by ward and district, and a user would have to locate themselves on the map by their street and find the number that corresponds to, and then find the address, and then find the little red star of the polling place. And when you look at a approach like this, a traditional GIS approach where you start with some data and produce maybe a paper map, you have all the data, but the end product is just that, often a PDF or a paper map. And because of the transition to so much of GIS living in the cloud, often there's a better way to do this. Again, if I lived one of these addresses, it might take a while to find exactly where I'm supposed to be going, especially if I'm new to the area or maybe not a map savvy person, as some people out there find things tricky. So how can we reimagine this just using Google Maps? Well, this example shows you a little bit of what's going on behind the scenes. We can take a list of addresses, so that's that same list that you saw on the previous slide, and the Google geocoder is taking that exact text and producing a latitude and longitude being fed the address. Now, the interesting thing about this process is, unlike a traditional geocoder, there's quite a bit of flexibility when it comes to what that input address looks like. It could, for example, be a place name like Lexington Avenue Firehouse, and it will still find it. It could have a typo or weird formatting or periods where they're not supposed to be. And because the Google geocoder is so robust, it can ignore all that stuff and still, with a very high degree of accuracy, find the exact point you need, because it's comparing your input data to their existing set of place data where they already know exactly where everything is. And once we have these geocoded addresses in the format of a latitude and longitude, that can be fed directly to an interactive map where now we're seeing that data come to life. So in pretty much one step between a list of addresses, we jump to a map with clickable symbols that we can look at in a little more detail here. So bringing back that same ward and precinct data layer, which they already nicely had in GIS format, we can overlay that and tap into some of the other things that the map platform offers, like getting directions via car, bike, or transit. Maybe I'm at work and want to get to my polling place by bike after work. Google can help me do that, and you can build that right into your application. Street View, for example, dropping in and understanding, all right, what is the accessibility of this building? Is there a ramp I can get in the front door, or am I going to need to find some side door with an elevator? These are things that you can explore without even leaving your house. Being able to search by address. I live here. Where should I go? Easy to solve. Maybe exploring nearby businesses. And again, the mobile device compatibility piece, designing it once, having it work across every platform can save a lot of time when you might be worrying about, all right, but I made a great application for my website, but as soon as I get onto a phone, now it's really hard to use. And let's not forget about the fact that there's a lot of different phone operating systems that all treat things differently. So Google makes that easy. And from just a teeny bit of effort, we're able to produce something really nice. But it goes a little beyond that in the interactivity piece. As you can see here, we're able to zoom right in, get that 3D view of the building, and go right into Street View so I can see exactly where I'd be walking in the door. And I think that's the one area that, without knowing anything about GIS or mapping, people really like about Google is it's one of the best representations of our world in a virtual environment. And the coverage and the data really makes that possible. And interestingly enough, the city here, to give them credit, they have adopted an interactive map for their constituents. So I think we were thinking on the same page there. But again, a process improvement piece going from something that might be a little tricky to read to something that's now super easy to use and provides just so much more depth. With Google, it's really easy. And with that, I'm hoping we have him on the line now, but I'd like to hand it over to Greg to tell us a little bit about what his organization has been doing with Google.
Sure, yeah. Greg Grube, I'm from the Wisconsin Elections Commission. I am the GIS election specialist here. So some of this predates my time at the agency, but what we've tried to do is similar to what Aaron is talking about. I mean, basically putting addresses in districts and then making sure that through that we can make sure that everyone is getting the correct ballot, which is really the goal here. making sure not only people are registered in the right place, but then getting the correct ballot. So I guess before we get into the kind of how Google fits into this, I just want to give a little background on our system. So we have a system called WisVote, which is our voter registration system. And there's a lot of different things that go into that, whether it's absentee ballots or setting up elections or printing ballots for clerks. But basically, the site is a place where our election clerks, we have 1,850 election clerks in the state of Wisconsin that run elections for their localities. And this is the place where they go to kind of manage that data. And this piece of it is basically how they assign voters to addresses and then how those addresses actually get placed. So in order to determine a voter's ballot, basically we need two pieces: what their address is, obviously what address they're tied to, and then what voting district that lands inside of. And then, like I mentioned here, the voting district is determined mostly through wards, but there's also a school district component that doesn't fit neatly into wards, so we have to kind of accommodate that. So on the next slide, just wanted to show a little bit how that looks in our system. So basically you can see in the map there that the little green pin is where the location of this address is. And so based on that location, you can see we're in the city of Middleton and Dane County, and then there's that district combo that's below it. And essentially what that is it's a unique identifier for, what district that person is, and then that unique identifier is tied to a ballot style. And so through the municipality, the ward, the school district, and the sanitary district, if there is one, it's a very rare case, but we have to accommodate it. Basically, the user can, the clerk in this case, or even our own staff here, can kind of know that it's tied to a specific ballot style. And then when you actually take that little address pin, if you do need to move it, if it's in the wrong place, for example, that will actually change based on where you're located. So on the next slide, talk a little bit more about that. Basically, then there, as you can see here, there are all of these red boxes that exist, and those red boxes show the district information. And it's, as you can see there, it's very complicated sometimes. Sometimes the city limits, and I'm sure a lot of you maybe are aware of this, but a lot of times the city limits aren't nice squares or nice geometry. In this case, it's kind of a Swiss village and city interact with each other. And so my job is to make sure that, because there's a lot of times annexations that happen constantly, and sometimes there's corrections that would even need to be made. Basically, it's important that those districts are set properly, because if you place one of these address pins on top of a house, you want to make sure that that is actually assigning them to the correct place. So, and then those ward shapes are actually something that we get from the state legislature and their IT branch, and then we take those and actually integrate them into our system. So those will be changing all the time. They're obviously set during the redistricting period, so every 10 years. But in the meantime, they will change. And so we have to be able to accommodate those changes before every election so that we are good. So for example, we have an election in April, so I just had to make changes to these last week so that any people that have been moved from one town to the city are actually going to be getting the correct ballot. And then, here's just one example of why this is so important that this is accurate, and why I think the Google Maps piece is really important to the process. So you can see here that address pin for this address is actually located not on a house, but in the middle of the road or near the road. And you can also see that because there's that red line there, it matters a lot where this is placed. So we rely a lot on our users to place these properly, but we also know that there's no way they're going to necessarily know how to do that unless we give them some tools to help. So we want them to go to their county GIS sites. We want them to hopefully know where some of these addresses are, but we also want to give them the tools to be able to move these if they need to be corrected. I don't have a chance to go through the millions of addresses in the state all the time, so we rely a lot on our clerks to go and do some of this fixing. So if you can see the satellite view and through Google Maps, then you can actually make sure that you're placing the person in the right spot and make sure that they're getting the ballot they're supposed to. And so by integrating this into the system, it's kind of a visual cue for the clerk and for our own users, instead of them just having to guess. Like Aaron was saying, if you're looking at a paper map, there's a lot more guesswork because you can't zoom into this kind of level to see that. So I think that's why at least us having the Google Maps piece integrated into our system has been really helpful, because when something goes wrong, we can point it out and we can find out why. And it hopefully becomes obvious based on the map, like, oh, of course this was in the wrong place. You placed it on the wrong side of the road. So I guess the problems become more obvious than if it was in a spreadsheet or something like that, which is the traditional way to kind of decide these things. And so I think that's everything I had.
Great. And I think Greg is able to stay on for the Q&A in case you have any questions geared toward him or what work his agency does. Just as a reminder, we're happy to field questions and stay on at the conclusion to make sure they get answered. So I wanted to finish up by just looking at how can AppGeo help in this process? Where do we come in? And I think it's worth noting, I was thinking about this a little bit today, and the fact that our organization has gone through some adjustments with working remotely, and it was surprisingly easy from a technological standpoint, just because over the past couple of years, AppGeo has made the transition to being a cloud-based company. And what that means is we are not only familiar with helping our customers work in the cloud, but all of the technology that we enable that process through lives in the cloud as well, which means we can be where you need us to be and be working throughout any situation, and we're here and ready to help. And I'd like to walk through a couple of ways that we're doing that with the Google Maps platform specifically. We have just rolled out this version of our support package. So many of you, or some of you, might be familiar with Spatial IQ. It's a program that we offer to various agencies as a support for geospatial services. And we're happy to now have a version of that specifically for the Google Maps platform itself. And what that looks like is it's really a journey. And we're here about helping you do more with your data. Spatial IQ allows you to understand your goals mutually and kind of review the platform, understand how the platform can help meet those goals. It can provide dedicated help desk hours around the clock and training resources that we have available as a Google Premier partner. It enables us to consult you on best practices, and behind the scenes, we're able to constantly monitor your usage, your performance, and come in and help with things like optimization, make your applications run more efficiently and at a lower cost for you. Additionally, a benefit of working with a partner is access to some of the volume tier discounts that we have, which can certainly help a lot when you're looking at a billing perspective. And we also have a quarterly success review we do with all of our customers on Spatial IQ, which involves, again, looking at best practices and discovering next steps for your project to help push it further and keep it on track. So a little bit about what it looks like getting started on the platform. Some of you might hopefully be excited to do that now, or have projects that you've been looking to roll out for a while. When you work with a partner like AppGeo, we can help set up your billing account and in a manner that fits your organization's needs. Google normally requires customers to put down a credit card that's kind of like a blank check when it comes to their usage. With AppGeo, we're able to actually define more specific terms and prepay where, it's more like a bank account versus a giving your teenager the credit card and saying have fun. And again, we've been working with cities and towns and states for many, many years and understand the billing cycles and funding cycles that you work within very closely and can help you fit Google Maps into that picture. We can also help create your project within Google Maps and walk you through the console, get you familiar with what you need to know to get started. That involves, enabling the APIs that we talked about here today. And a big part of what we've been able to help with is identifying exactly which ones of those are best for the task. In many ways, there's more than one way to accomplish the same process, and we can help you do that most efficiently. And lastly, just provisioning your key, which will plug right into the application that you might want to start building and set up all sorts of monitoring and provisioning that will help make sure that your data and licensing is secured to the individuals that you want to have access to it. So with that, I'd like to go right into our Q&A. We have a handful of minutes here before 3, but I'm happy to stay on longer than that if anyone has questions. I want to thank all of you for joining us as well. It's certainly a week that we're seeing a lot of change in many ways, but we're fully online and ready to help your organization. So again, we thank you for making the time to attend today.
And yeah, we definitely do have some questions, so please do stick around for Q&A. And this isn't the end of questions. If anything comes to your mind during the Q&A session, we're happy to answer any new questions as well. So I'll jump right into our first question. When you make a custom app, does it need to be delivered in a downloadable app? How do you get this info, like polling places, to the users?
Sure.
So I can, yeah, you got that?
I think I understand. So again, yeah, GIS applications have evolved quite a bit as the web has become now the primary way to access them. And when it comes to the Google Map platform, the nice thing is there actually is nothing to download on the end. There are ways of building applications that have these as components, but to simply create a map, the majority of our users are doing that directly within a web page. So anything that can access the internet can access all of the data that you've shared because it lives in the cloud. You don't need to have things like a shapefile or a KMZ to actually share that data with the end user. It's just natively being interpreted through a database and being displayed on the map. So you can think of Google Map as a lens into the data that you may already have, and a lot of tools to shape the way that you're able to interface with that data, I think is a smart way to look at it, and a little different than a traditional GIS desktop application where you have to have software installed and the data downloaded before you can kind of get going. Hopefully that helps.
Perfect. And feel free to build on any of these questions as well if there's a part 2 to the question. So we do have a number of other questions that have come in. Can you have the API read REST services from an ArcGIS server?
Sure thing. We've definitely seen a lot of cross-compatibility between these different services, and the fact that they are in an API format means that programmatically there's a lot of ways to interface between them. When it comes to your data source, it actually matters more kind of how the data is formatted rather than where it's coming from. So we could probably follow up with you more in detail if you had a specific project in mind, but I believe that is possible to grab from an outside data source and pull it into Google Maps. we do understand every organization and software has its own terms of service, and we understand the way that Google's works very well. And we tend to pride ourselves on knowing exactly what you can do and kind of push the boundaries when it comes to bringing more into the Google platform. So overlaying a lot of custom data, however it may have started out, we're familiar with doing that, as you have seen a little bit with like that Rutgers example.
And we're also getting a follow-up on that same question. Before we jump to the next one, I'll finish. Have you done that before? I actually want to just mention a little bit that not just with ARC, like when it comes to other tools like Cardo, Google Maps plays very nicely with that. But have we done that before with ArcGIS? And
I'd be surprised if we hadn't, just because of the number of groups that we've worked with who, many of them are longtime Esri users and are looking for some more flexible ways to, bring that data to their customers, their constituents through maybe a simpler, lighter weight interface. So I might have to follow back up with you on email for the specific projects where we've done that, but our team's been working with these technologies for a number of years now, and Esri since pretty much the dawn of that company's existence as well. So I think we have a good amount of cross-pollination.
There's definitely a good chance that we could expand on that, and we can reach out to the question afterwards as well. No problem.
Absolutely.
We're happy to expand more on that. So we do have a follow-up from earlier. So when we're talking about building apps that have Google Maps APIs, we have a question here. So would a user have to click a link in a website to launch Google Maps, or would they view Google Maps within their browser? And I actually want to start answering that question just a little bit, and you can piggyback off that,
Sure.
Aaron. And that is that, Google Maps APIs are embedded in a number of fashions. So if it's HTML, if it's embedded through like a classic iframe, or if it's JavaScript code, there are a number of ways that these different APIs can play into how they would be embedded, but it would not be through a maps.google.com app. It would be through whatever app you're building, whatever the address, or if it is an app like a true mobile application, it would be hosted through there, and then the APIs run through these embedded codes. Aaron, could you build on that a little bit more as well?
Sure thing. An easy way to exemplify this, if you look at your favorite store, oftentimes they'll build their store locator on Google Maps. So you'd go to a web page and you're seeing a Google map, but it's populated with, all the pins that represent that store's locations. And that's one use case of the Maps platform that's been pretty widespread. But again, it can be set up so there's nothing extra to click, nothing to download. It's just there on the page alongside all the rest of the information. And there's been quite a bit of creative ways we've seen people integrate maps into the rest of their data, and especially as we go more toward a multimedia enabled websites, it's really seamless.
Great. I hope that answers that question as well, and we can also build off that a little bit more on how these APIs embed and talk to these different sites and applications. It is now 3:00, but we will continue going through all these Q&As or the questions, before the end of the session. So feel free to keep asking. We will stay on as long as it takes. I will run one right by Greg in case he has to hop. Greg, I'm assuming this means with a Google Maps API involved, but do you have examples of a public-facing mapping application as well?
Yeah, so we do use Google on our public-facing site, which is called MyVote, Wisconsin. It's a very simple version. It's not as complicated as the version I was showing. Basically, what we do is when you put in your address, when you're looking for your polling place, if you put in your address, it actually returns the location of your polling place, and it puts that on top of a Google map. It's not as interactive as what I was showing earlier, but yeah, and basically it will just show the polling place location. It doesn't actually route you from the address that you gave to the polling place. It gives a link so you can do that, where it actually, if you click on it, sends you to the directions page on Google. So it links to like an external Google version, but it does show like a pin on a map and then gives you the name of the polling place. So that's the only version that we're really using, at least the Google Maps piece on our public site. But it's kind of a simplified version of what I was showing before.
Perfect. And so that's myvote. Is it myvote.gov or is it?
Yes, myvote.wi.gov.
Yeah, perfect. Awesome. We do have one more question. That is, it sounds like the Google Maps APIs are designed to work in combination. Is that the case? And how do I know which ones fit my use case? I can start answering that.
Sure.
Yes, absolutely. There are, Google APIs that are designed to work in combination. Most of the time, that is the case that folks are using more than one API per application or per site they're developing. How do I know if it fits your use case? Feel free to reach out to us at AppGeo. I know everybody here has got an email from me at jfrazik@appgeo.com, but we would love to hear more about what kind of apps people are building, how they're building them, what technologies they're used to using, what technologies they want to use. That's definitely something that we're always keen on knowing more about. So feel free to reach out to us directly. Without knowing more about your use case, it would be tough to answer this question off the cuff, but I do appreciate asking it.
Absolutely. I think a good way of looking at it is, Google's making the Legos, but we can help build them into the end result that you're looking for. And of course, there's a lot of ways to arrange the pieces and get a little creative with it at times. So that's where we can really help. And it's an area that we've been heavily investing into and are hoping to grow even further, is consulting around choosing not only the right API, but the right combination to answer the questions that you might have.
Excellent. Thank you for that answer as well, Aaron. And Greg, thank you for joining us as our guest presenter today. There's obviously a number of people that have come and we're very happy that somebody that's in the thick of it can show off real world examples of how powerful these APIs can be. And once again, thank you everybody from AppGeo. This is Jordan Frazik. We hope you have a great rest of the week.
Yep. Thank you, everybody. And we'll distribute a recording of this webinar after the conclusion, in case you want to go back or share it with anybody.
Perfect. Thank you, Aaron. Thanks, everybody. Take care.